This is a second video on arithmetic expressions, and I would like to show you a little bit about how to round as well as some of the shortcut operators. So we'll start out and we'll create a few variables. Whether we need them all, we're not sure, but now a lot of people ask, how do you round? Because one of the things we saw previously was that when we assign something with a fraction to an int, the fraction gets chopped. It doesn't do a round, it does a chop. So let's just say that d equals 47.2. So in order to round this, one of the simple ways is if we do a printf, and I'm going to put 0.0LF, and that's saying I want 0 places after the decimal point, so it should round to the nearest whole number. I'm going to say d equals in front of that, just so we know what it is when it prints it out, comma, and print out d. Okay, so if we run this, we see that d equals 47, and it's been rounded down, which is what you would expect. Now let's just make this 47.8 and run it again. Now it's been rounded up to 48. So the rounding works when you do a printf. But what if you want to round it yourself? Okay, rounding it yourself takes advantage of a trick. And the trick is that any number who's got a fraction greater than 0.5 is going to round up. So what you do is you add 0.5 onto it, and if it's 0.5 or greater, it goes to the next whole number. So 47.8 plus a half, or 0.5, is going to be 48.3, and then you chop the fraction and you get 48. But if it was 47.2, if you add 0.5, it becomes 47.7. You chop the fraction and it rounds down to 47. So it only rounds up if it's already got a value of 0.5 or greater. So what I'm going to do is I'm going to say that c equals d plus 0.5. And then I'm going to print f and I'm going to print out %d because I already converted it to an integer in C. Okay, so my round will be my way of rounding it, where I'm doing it manually. We'll run this, and it says my round is 48. I forgot my new line previously, so I'll put that in. So my round gives 48 as well. Now, if I do 47.2 and run it, you see that it rounds down to 47, just like it does with the printf. So if a fraction in d is greater than 0.5, it rounds up. Now, we got to be aware of a lot of the things with respect to what's an int and what's a float. So if we say b equals 2 divided by 3, you would think it's 0.66. Actually, let's just say we want d because we want to show you with a thing that has got a fraction. And I'm going to say d equals percent 0.2 for 2 places after a decimal point, LF for long format because it's a double, backslash n at the end of that, and I'm going to print out d. Okay, let's just run this. And it says d equals 0.0, not 2/3, which should be 0.66, but 0.0. The reason it's 0.0 is because 2 is an int and 3 is an int. If we want these to become floating points, there's 2 ways of doing it. We can cast it, which is what we did in our previous video, or we can put in a decimal point. And as soon as we put in a decimal point, it realizes, hey, that's not an int, that is a floating point number. And now I've got an int divided by a floating point. That has to be done in floating point arithmetic. So I retain the fraction, assign it to something which is a float that holds the fraction, and it should print out the fraction. And we should see 0.67 if it rounds properly. And there we have it, d equals 0.67. So we do get proper retaining of the fraction. Now, there's a couple of shortcuts I want to show you. A lot of people say, let's just say b equals 5. And then I can say b equals b star 2. Now, a lot of people do operations like this where they take the value of the variable itself, do something to it, and then assign it to itself. So they modify it. This is the long way of doing it. But we can write exactly the same expression in a much shorter way. And that is b star equals 2. And that's our shortcut notation. It does exactly what this does. B equals b times 2, but it's a shortcut. It's a little quicker to type. There's another shortcut we want to look at, and a lot of times people want to add 1 onto a number. So they say, I might as well print out b here. We'll just run that so you can see what it does. Now, b started at 5. We multiplied it by 2, became 10. We multiplied by 2 again. It's now 20. So that's how it gets 20. So it's now got a value of 20. I could say b plus equals 1, and then print out b again. And you're going to see that that adds 1 to it, and it should make it 21. And you see it's 21, which is what you would expect. And there's an even shorter way of writing it. Instead of saying b plus equals 1, you can say b plus plus. And plus plus is a short way of saying add 1 to it. Minus minus is a short way of subtracting 1. So because people often add or subtract 1, there's a really quick shortcut for this. So let's do another printf of b. And now we'll see that the 21 becomes 22. So it becomes 22, and that's good. Now, this is where it gets tricky. Let's just say that I've got C equals 5. Just for easy arithmetic, we'll make a nice number. And I'm going to say that A equals B plus 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 C. Okay. So, and then what I'm going to do is I'm going to print out the value of A. So I'm going to switch this to say A. And you would expect that it's going to add 1 to B. And I think it was a 22. So it should become 23 plus 5 is 28. And I want to print out A equals, but I also want to print out what B equals. And that's how we can print out multiple values in a printf, because the first format code matches with the first variable, the second format code matches with the second variable. Okay. So I think we had 22. Let's see what it is now. Okay, so we got B up to 22. Now we see that A equals 27 and B equals 23. But let's look back at the code. Right there, B came into this expression with a value of 22. 22 plus 5 is 27, but it added 1 to it and it became 23. So how does this work? You would have thought it would add 1, get 23 plus 5 and make it 28, but its A is only 27 at the end. So the way it works is this is called a post increment. And in a post increment, B is incremented after it's used. So it's used in the expression B plus C, 22 plus 5 is 27, it's assigned A. After it evaluates that expression, it adds 1 onto B afterwards, which is why it uses its value, and after it's been used in that expression, it adds 1 to it. Now, we can do the opposite, and we can do a pre-increment. So let's try a pre-increment. And what I'm going to do is I'm going to say B equals 20 to get it back to a reasonable number, but we know what it is. And I'm going to copy this, put it down there. And now I'm going to do a pre-increment, which means instead of saying B plus plus, I'm going to say plus plus B. And that means it will increment it before it uses it in the expression. Okay, and then we're going to print out A and B. So B starts out at 20. It's going to be pre-incremented to become 21. We're going to add 5, and A should be 26 now, and B should be 21. So A is 26, B is 21, because it added on to the value of B before it used it in the expression, whereas with the post increment, it used it in the expression before it added on the value. So that's the difference between a pre-increment and a post-increment. Okay, that's the end of this little section on expressions. Next, we'll take a look at relational expressions.